Hey guys, how's it going? Like I said, I wanted to get back with you and do a review from the lesson that I did yesterday. I know it can be extremely tricky, that lesson, and I'm going to just work, I think, example number 61 on page 201. That's the problem I'm going to work and just show you how it can be worked out a couple different ways and how sometimes simplifying it can be pretty difficult. It's not a new lesson. I'll try to do the new lessons on Monday, Wednesdays, and Fridays, and then I'll try to do some sort of a review on Tuesdays and Thursdays. But before we get started, I've got some special guests here who were wanting to introduce themselves to you. So at this time, here are my kids.
My name's Cooper Bishop Wright.
This is my son, Cooper, and he is, how old are you, Cooper?
8.
He's 8 years old. All right, see you, buddy. And here's my daughter.
Hi, my name is Peyton Bishop Wright.
Your name is Peyton Elizabeth Wright.
Oh, okay.
Peyton Elizabeth Wright. And how old are you, Peyton?
6.
All right, so that's my kids. All right, y'all go play. So anyways, they have been talking to me about wanting, they think I'm famous or something since we're doing videos on YouTube. So anyways, so let's go ahead and get started. And I want to show you number 61 and see if you guys can understand this. On 61, it says this. Okay, it says 1 minus cosine theta times 1 plus secant theta. Okay? So anytime I see that or I have a problem like that, I'm going to go back to my old rules. Okay? I'm going to go back to my old rules of knowing that, hey, we're doing FOIL method. So we're going to handle this problem doing the FOIL method. So that's first, outside, inside, last. So 1 times 1 is 1. 1 times secant is secant. Negative cosine times 1 is negative cosine. And negative cosine times positive secant is negative cosine theta secant theta. All right. So, again, I just want you to understand that we're just doing the exact same thing there, okay? As a regular FOIL problem, okay? So it's just multiplying two things together. Now we want to get to the point where we talk about changing everything to sine and cosine. So at this time, that is what I'm going to do. I'm going to change everything that is not in terms of sine or cosine into sine or cosine. So when I do that, or when I look at it for this problem, we can say, all right, so I guess maybe I misspoke a little bit right there. I want to leave this secant alone. I'm just going to leave this alone because I want to show you something. So it's going to be 1 plus secant theta minus cosine theta. But then when I have this cosine times secant, that's the same thing as saying minus cosine theta times secant is just 1 over cosine. So we're going to change that. Okay? So again, I apologize right there. I know I told you, hey, let's change everything to sine and cosine. We could have 100% done that and been fine. But I wanted to leave secant as secant because I want to show you something and see if it works and try to make sure that you don't get confused with this. Okay? So again, I just changed this secant in terms of cosine because I know it'll cancel now. So this gives me 1 plus secant theta minus cosine theta. And then right here I have negative cosine times 1 over cosine. Those cancel, guys, and that's just minus 1. Okay? Minus 1. So now I have a positive 1 and a negative 1. Those cancel. And the only thing I have left is secant theta minus cosine theta. Now, this is kind of the age-old question of when something says simplify, when do I know it's done? Okay? Is this the answer? if I were giving you this problem and it was not multiple choice, and I said simplify, I would accept the answer of secant theta minus cosine theta. Okay, 100%. But now, a lot of times, or sometimes, if we're taking these tests and they're multiple choice, unfortunately, secant theta minus cosine theta may not even be an answer. It may not be a choice. So, why is it, or how is it, or how do we know when to stop? And guys, sometimes the answer is we really don't. Okay, that's what makes. At the start of these lessons, I said, hey, you know, sometimes when we have something that says simplify, it's a lot more difficult than if we have evaluate, because evaluate, typically you get an answer. For simplify, you can get several different answers, okay? So this is a good answer. This is a fine answer, but I don't know if it's our best answer, or necessarily if we were dealing with a multiple choice problem, if it would be one of the answer choices. So if it wasn't an answer choice, how can we, or why is it not? And it comes back to okay, when I worked the problem, I didn't put everything in terms of sine and cosine to begin with. Remember, I said, we got the secant, let's leave it alone, okay? So now, let's change everything into terms of sine and cosine. And again, I'm not saying this answer's wrong, but I'm saying if you don't see this answer, if it was a multiple choice or something of that nature, then I want you to understand why, okay? So I'm going to go ahead now and change this secant to terms of sine and cosine. So that's 1 over cosine theta minus cosine theta. Now we are simply subtracting two fractions, or a fraction and a number, okay, so to speak. So we're going to have to find a common denominator. Common denominator is cosine theta. So this one doesn't change. This one goes into cosine theta. I'm sorry if you can't see that. I'll move this up to the top. 1 goes into cosine theta times cosine theta is cosine squared theta. Okay? So that's what I have here. And so we're going to move this up here. Okay? I'll move this up to the top so hopefully you can see it better. So now, again, at the bottom there, if you can see, I've got 1 over cosine theta minus cosine squared theta over cosine theta. Write down the denominator one time and then write down the numerator. Okay? So that's going to be cosine theta over, below 1 minus cosine squared theta. Okay? So that's what we have now. All right, so up top, I've got 1 minus cosine squared theta. That, remember, is the same thing, and I'm writing it right up here. Sine squared theta plus cosine squared theta is equal to 1. If I move this over, right, that would be sine squared theta is equal to 1 minus cosine squared theta. So 1 minus cosine squared theta is sine squared theta over cosine theta. Okay? Now, I'm not going to say this one's simplified, because a lot of times for something to be simplified, it does not need to be a quotient. It does not need to have a denominator. So again, what we can do right here is we can rewrite this. And this is a little bit tricky, okay? This becomes slightly tricky. So what I'm going to do is I've got two sines up top, sine squared, so it's sine times sine, and on the bottom I just have cosine. So I can rewrite this as sine theta over cosine theta times sine theta. Okay, you see that? Because sine times sine is sine squared. So I'm just rewriting this, all right? Now, sine over cosine is tangent. Okay, that's tangent theta times sine theta, and then that is another potential simplification of this problem. Okay, so I want you to see that, yes, we got here, okay, we did this, and we looked at it as secant theta minus cosine theta, but then I said, hey, you know what? I've never changed everything into terms of sine and cosine. So I did that, and I simplified further, so to speak. and ended up with tangent theta sine theta, okay, which is multiplication. So we kind of consider that to be simplified a little bit better, simply because we're just multiplying two quantities together, so to speak, okay, as opposed to subtracting them. And when you subtract, if you have denominators, you have to do a little bit more evaluating and things of that nature. So anyways, but mainly for today, like I said, I just wanted to show you how to work this problem, try to give you a little backdrop on that, and like I said, my kids wanted to get on camera themselves. So anyways, but for today, I just wanted to review that. Tomorrow I'll come back with a new lesson, and we will go from there. Alrighty. Well, I hope everybody has a great day, and I hope I get to see all of you soon.